Hi guys, so this week we are going over special products of polynomials when we're multiplying. So last week we learned if we had two different binomials and we multiplied them, we could use the FOIL method to multiply them all out and simplify. This week's material gives us a couple shortcuts to use depending on what types of binomials I'm multiplying together. So if I have a binomial and we're just multiplying it by itself, whether it has a plus or a minus sign, we have two different rules that go along with that. And then if I have two binomials that are exactly the same except one's a plus sign, one's a minus sign, then I also have its own special rule to go along with that. So according to my rule, if I have 7x plus 2 and I square that, if I bring that to the power of 2, my first term is going to be squared, right? So the a here is represented by the 7x, and in my shortcut, we're taking a squared. So in this case, 7x squared would be 49x squared, right? Because I have to square the 7 and I'd have to square the x. Then I would take plus, right? And then I'm multiplying 2 times the first term times the second term. So 2 times 7x is 14x, and then I have to also multiply it by b, which is represented by 2. So 14x times 2 gives me plus 28x. And then our final step is b squared, which in this case is 2, so we say plus 4 when we square 2. So that's our shortcut method, right? We're getting the shortcut because when we FOIL it, right, if I show you how we FOIL it, we're going to end up with the same answer. Just helps us a little bit easier if we have the shortcut. So 7x plus 2 squared is really 7x plus 2 times 7x plus 2. If I did my FOIL method, I'd do my first terms. 7x times 7x, we get 49x squared, right? Our outer terms, 7x times 2 gives me plus 14x. Our inner terms, 2 times 7x gives us 14x. And then our last terms, the 2 times 2 gives us plus 4. And when we simplify this, we still get 49x squared plus 28x plus 4. So rather than going through this entire FOIL method, if I see I have a binomial multiplied by the same binomial, right, it's multiplied by itself, I don't have to go through my FOIL method if I remember this shortcut. Okay, so this section is all about using the shortcuts. In the future, right, if I give you two binomials and I tell you to multiply them, you can use your shortcut rules, right? Or at the very least, you know how to get the same answer when you multiply. Okay, so if you feel comfortable using the shortcuts, use your shortcuts. For this week, I would like you to use them, but from here on out, after this week, if you feel more comfortable just doing your FOIL method, then just do the FOIL method. It's just a bit more work here. Okay. So that was our first example using the first shortcut from our notes. Our second example is pretty similar, except now I have a minus sign. So we can see when I have a minus sign in my binomial between my two shortcuts, just this first sign changes to a negative. Okay, so again, if I followed the shortcut, my first term is a squared. So my first term would be 3x squared, which would give me 9x squared. Okay, then I would minus 2 times a, right? So 2 times 3x is 6x, times your b value, which is 4. So 6x times 4 would give us minus 24x. And then we would have plus b squared, so plus 16. So in your shortcut, this negative is taking care of the negative here. So when we went through and we said 2 times a times b, we did 2 times 3x times 4 because the negative was already taken into consideration in our shortcut when we wrote this negative here. But again, let's see what we can do when we do the FOIL method. It should end up being the same. So again, 3x minus 4 squared is really 3x minus 4 times 3x minus 4. Okay, so if we go through the FOIL method, we would multiply our first terms. So 3x times 3x gives us 9x squared. Our outer terms, 3x times negative 4 gives us negative 12x. Negative 4 times 3x gives us negative 12x. And negative 4 times negative 4 gives us plus 16. So when we simplify this, we get 9x squared minus 24x plus 16, which is exactly what we got with our shortcut. Okay, so it ends up being the same. I'm doing the FOIL method to show you that we're still getting the same answers. This is where our shortcuts derive from. So anytime you have the same thing, you're multiplying it by itself, you don't have to go through this process. You can just use your shortcut formula here. Okay, this last example is a little bit different because we pretty much have the same exact binomial, except one has a plus sign and one has a minus sign. Okay, according to our shortcut, we would just say whatever the a term is, right, because they're the same in both, that a term is going to be squared, right? So for this one, we would take 4x and we would square it to get 16x squared. And then we would do minus our b squared. And in this case, our b is y, so minus y squared, which is pretty easy according to our shortcut, right? But we want to see how we're getting that formula, where that shortcut's coming from. So we're going to FOIL, right? Our first terms, the 4x times 4x, gives us 16x squared. All right, our outer terms, we would get plus 4xy, all right? And then when we multiply this one, we would get minus 4xy. And then we can distribute again, right? Do our last terms, we get negative y squared when I multiply the negative y times the y. So when I go through this, right, I notice when I go to combine, I have a positive 4xy and I have a negative 4xy, right? These are pretty much canceling themselves out, right? It's the same term except one's a positive, one's a negative, so they're going away. They're canceling out. So we would end up with 16x squared minus y squared. Okay, so the right column, we're showing you how these shortcuts are used, right, without having to go through this process. This left column is showing you how we're getting these shortcuts, where they're being derived from when we do the FOIL method. So these shortcuts will work for any of these types of binomials, whether you're multiplying it by itself with a plus or a minus sign, or whether you're multiplying it by itself with one plus and one minus. Okay, the binomials pretty much have to be exactly the same for these shortcuts to work. Okay, so as always, send me an email if you have any questions, and we'll go from there. Thanks.